Hi class. Let's continue on with the example I started on Monday. This will be example two, a further uh, demonstration of a basic Java inheritance example. So I'm going to pick up with the source code that we started on Monday. And so some of the things we need to do is that we need to add functionality to our superclass bank account. Now, as we discussed on Monday, we have the constructor and we access each account through a unique account ID, which is an integer. And of course, accounts have to be affiliated with an account holder's first name and an account holder's last name. So what are some additional functions that we need with our bank account class? Well, of course, we need to be able to deposit money into an account. That makes sense. So let's have a public method, public void deposit. And what do we deposit into an account? Well, we have deposit money. And what is money? Well, it's uh, a lot of numbers to the left of the decimal, hopefully, and then two digits to the right of the decimal. And so that basically makes that kind of number a double, okay, or a float, but we'll go ahead and use double. And then we'll let the amount be the quantity deposited. Um, so with the amount, what do you do with the amount? Well, you add it to your running balance. So how is that? Okay, remember, balance is a private field, which is the current running total of the money in the account, whether it's positive or negative. So I'm seeing oops, I didn't mean to type double, the hazards of typing and talking at the same time, right? You're prone to error. Okay, so let's make this amount. Yep. Okay, so this is our deposit. And of course, other things that we do probably more often with our accounts than deposit um, is that we withdraw, right? We withdraw monies from our account. So public void withdraw. And so withdrawals, of course, um, deduct money from our account. So what do? We pass in another double amount. Okay, now this amount is not the same as the amount passed to the deposit method. Okay, and so what does that do? How does that affect our balance? So balance is equal to balance minus amount. So does anything else happen with withdrawal? I don't think so. Okay, not not at the superclass level. All right. Other things we need to do. Okay, so we last class we talked about setting an account ID. So now if we want to, for instance, print out all of the accounts in this particular bank account, we have to, of course, get the account ID. So we need a getter for the account ID, and so the getter will return the an account ID for or return an account ID. So return the classes return account ID. Now remember, account ID is private with respect to the superclass. Okay, other things we need to know. Okay, we'd like to know the current account balance. Okay, so public double get balance. So this will be the getter for the balance. Get balance. And this will just simply return the private field or data return balance. Okay, we don't need a setter for the balance because the setters for the balance are, of course, the deposit method and the withdrawal. These are essentially setters. Okay. Okay. Now, other things we like to do is, and I'll probably reserve this for the next discussion, but at some point we would like to print print out the account balance, okay, in using currency format. And I alluded to this in the first demonstration. This particular import of this Java library, java.text, contains methods for formatting currency, formatting a double as a currency value. So I'll discuss that next. But for now, what I want to do is I want to put a placeholder for the class, okay? and I'll explain more about what toString does um, later. Okay, so this kind of builds out the functionality with the exception of the toString method. Um, Oops, I guess I better stub it out. Let's just return a null for now to satisfy the requirements. So this kind of builds out the functionality of the superclass bank account. Now, okay, so now let's go on to our checking account class. But before I go on, I want to save all in case my machine crashes. So in our checking account class, it's what do we have so far? We have a method to set the interest rate. Now, one of the program requirements was that if the account balance falls below zero, then we have to post a penalty. Okay, so how do we do that? Well, we need a method. So let's do this. Now, again, what I'm doing, the things that I'm doing, you don't have to do. Okay, this is just a walkthrough of some thoughts I have about this particular critical thinking assignment for Module 1. Okay, so what I want is I want a process withdrawal method that returns a string. And so uh, basically what it will do is it will print the string representation of the account balance, whether it's in currency format. So um, if the account balance falls below zero, then of course we like to enclose the monetary amount in parentheses to use, that's the accounting format for negative balances, to put the number in parentheses. And so all of that has to be formatted as a string since we're going to be using non-numeric characters as the output. So uh, we have an overdraft fee, okay, and I believe in the specifications it was set at $30 if I recall. If not, you can just go ahead and make it an appropriate value. So, okay, so overdraft fee is $30. So that's assessed if the account balance falls below zero. All right, so now what do we do? So since the checking account class is a child of the banking account class, we can just simply call the super withdrawal method, right? Okay, and that would be, of course, the amount. So notice that I used the keyword super to invoke the ancestor method or the parent method of withdrawal. Okay, and I use super to reference it. Now, so if okay, if the balance again, oops, check that. If the balance, the account balance, which we do by using the getter method, which is defined in the superclass, is less than zero, okay, then we need to ding the customer with a fee, right? So what do we do here? We have to withdraw $30 from the account, an additional $30. So in this case, whatever that is. Now again, remember, I defined overdraft fee at the top of the method. Uh, um, so that the method is extensible enough in case the overdraft fee changes. Now I was kind of lazy, right, in doing this. I could have, or probably should have, made it a private element of the class. So I could have said private int overdraft fee, okay, if I can spell, okay, so private int overdraft fee, and then I can do in my constructor class, okay, I can define a constructor class. I can say checking account, here's my constructor, and I can say overdraft fee equals to 30 in my initial value. And then I can do this dot overdraft fee. So I can do something like this, okay? All right. Okay, notice the red lines under the method because I need a return statement. So we'll get to that shortly. All right, so again, my data are private. Okay, uh, so what do we do next? We we need to return what? The uh, the information about this particular account. So super dot toString. Okay, all right. And so this will print the information about the account. And notice that right now the toString method is nothing more than a returns nothing. So this will return nothing until we discuss further about this. Okay, so if the balance is less than 0, then we ding the account holder with a fee and return the account information. Okay, else, okay, if the account is greater than or equal to 0, then all we have to do is return. Well, what do we return? We return information about the checking account. Return this dot toString. Okay, and so in this case, this particular class doesn't have a toString method. So what we need to do is we need to implement a toString method for this particular class. So let's go public string toString. Okay, and so what can this do? So what can we say? What's useful to say in our toString method? We could say return, okay, super dot account, super dot toString, okay, or something like super dot toString plus what? Interest rate equals what? Can print out information about the interest rate. String dot value of what? Sorry, I got too aggressive on the auto sense. String dot value of the interest rate, right? So we could say this dot interest rate. Okay, so we can print out information about the interest rate, and it's a percentage, right? Okay, so we'll include the requirement to print out the interest rate along with the account information. So in our next discussion, we'll talk more about the toString methodologies. Okay, so class methods. In this particular discussion, we talked about more functions of the bank account class and the checking account class. And then we talked about leveraging the superclass methods in the child class. So let me save all. And just to make sure that I haven't broken anything, we'll go ahead and run the program. Okay, so A1, B2, put in some bogus data, it doesn't matter. Okay, so the program is not broken yet. Okay, so far so good. All right, so we'll press on in our next discussion. Have a great day, and if you have any questions about this particular video, feel free to post in the Module 1 discussion forum, or if you have any concerns or if you've seen any mistakes that I made, I'm most anxious to hear from you. So have a great day.